how we can use all these fundamental identities that we have derived in our previous video to solve some questions. And it's going to be lovely. Alright, so let's start with our first question. Oh, let me write it. So the first question, if tan theta. Now, as far as this video is concerned, I don't want you to forget this. All students take up first quadrant, second quadrant, third quadrant, and the fourth quadrant. Don't forget. All means all the trigonometric functions are all going to be positive. Only sine is positive. Only tan is positive. Only cos is positive. The rest that will fall under that quadrant will be negative. So let's look at this question. If tan theta is negative 5/3 and theta is in quadrant 2, find each of the functional values for A, sec theta, B, sin theta, and C, that is, wow, cos of that. Very good. So now let's go and look at it. And you're going to enjoy. Now, if tan theta is equal to negative 5/3 and theta is in quadrant 2, in fact, before the question tell you, this is the concept. Before the question tell you that a theta is in quadrant 2, you yourself you have to know that the argument is in quadrant 2. Yes, because for quadrant 2, only sign is positive. Only sign is positive. Therefore, for you to be given tan, know that tan is equal to negative 5/3. And that is why on the second quadrant, tan is negative, cos 2 will be negative. Alright? Cos 2 will be negative. So for sine, it's going to be positive. So that's why tan theta is negative 5/3. What is that? Very good. So now let's go for the first one. A, sec theta. So don't forget, we are working in the second quadrant. So we are going to work sec theta in the second quadrant. So we go for a fundamental identity that is going to link up with sec theta so that we can find it. And don't forget that we have tan theta already to be negative 3/5. Sorry, negative 5/3. Okay, so we know from the fundamental identities that 1 plus tan square theta is equal to sec square theta. Therefore, by substitution, we can get 1 plus, this is what? Negative 5/3 squared is equal to sec square theta. And this is going to give us a positive output. Alright. Now, this is going to be 25 over 5 times 25 greater than 9. So this is going to give us 25/9. So you just add 1 to 25 over now, and you are going to get 34 over 9. 34 over 9, which is going to be equal to sec square theta. Don't forget you are looking for sec theta. So for you to get sec theta here, what will you do? You square root both sides. So sec theta is going to be equal to, now anytime you take a square root, don't forget to bring plus or minus, please. This is mathematics. So you get 34 over 9, right? And square root of 34 over 9, square root of 34 over 9, we are going to get that to 3. It's still plus or minus. Then you conclude. Now, is it going to be plus or minus? This is the question. And the only concept or the only idea that is going to help you is our students take calculus. And don't forget, for the question, you are working in quadrant 2. So in quadrant 2, only sign is positive. In this sign, no, that is sec. That means that sec is also going to be negative because only sign is positive. Right? Very good. So, or let me say, only sign and its reciprocal is going to be positive. So, for sec, which is a reciprocal of cos, is going to be negative. So, therefore, sec theta is negative square root of 34 over 3. Very good. Let's look at the second one, which is the b. I'll write it in it. So we are using our known tan theta. So the b, we have to look for sine theta. Alright. So from what you in mathematics we move from known to unknown. So from what you know tan theta, you know sec theta. Which of the fundamental identities is going to help you to get sine theta? It's going to help you to get sine theta. Now, you can know that tan theta, you know that tan theta is sine theta over cos theta. Very good. But we know tan theta, we don't know sine theta, that's what we are going for. And we don't know cos theta. Yeah, we don't know cos theta, but we know the reciprocal of sec. Of course, and that is sec. Very good. So here we know that sec, or we can put it that way. We know that cos theta is going to 1 over sec theta. Okay. If sec theta is equal to 1 over cos, then cos theta is equal to 1 over sec. If you are confused, change of subjects. Alright. I'm not saying change the subject like trigonometry. I mean make cos theta the subject. Sec theta is equal to 1 over cos. So make cos the subject. You're going to get it. Very good. Let's move on. So now cos theta is going to be 1 over sec is negative square root of 34 over 3. Therefore, we are going to get this to be negative 3 over square root of 34. And you know, with this, we have to rationalize it. Alright? So when you rationalize it, you are going to get don't forget, we are not looking for cos. we are not looking for cos, we are rather looking for sine. Alright. But cos theta will be equal to 3 over negative 3 over square root of 34. Rationalize it. So that is going to give us cos theta is going to be equal to negative 3 square root of 34 over 34. Alright. Alright, so that is that for cos theta. And now that we know that for cos theta, we can easily go for sine because we know that cos squared theta plus sine squared theta is equal to 1. Therefore, sine squared theta is going to be 1 minus cos squared theta. Okay? So we get sine squared theta is equal to 1 minus cos is it, so 1 minus negative 3 square root of 34 over 34 all squared. Right? And after you're going to punch all these on calculator, and whatever you get, you take the square root of it. And when you do that, you are going to get sine theta to be equal to 5 square root of 34 over 34. Alright, so that is that for cos sine theta. Alright, now we know sine theta, we know sec theta, we know tan theta from the question, and we know cos theta. So let's go for cos. Well, let's go for cos. So for us to get cos, don't forget it's cos negative theta. And you know that cos negative theta will be equal to cos negative theta over sine negative theta. And this is going to give you cos theta over negative sine theta. Beautiful. So what is cos theta? We had plowed that part, but we know that that one was to be okay. You can go with this idea. You can use this idea, okay? Or you can say that the whole of this is tan theta. Is that also very good? So negative tan theta. This is tan theta. And you know from the question tan theta is negative 5 over 3. Therefore, we are going to get I'm coming from the angle that, sorry, this is 1 over tan theta, I mean the reciprocal of it, right? You can use the value for cos theta and sin theta to find for cot theta, to find for cot of negative theta. Or you can also say that cot negative theta is equal to negative 1 over tan theta. That's what I mean. Alright, that's what I mean. Because even if you make here negative theta, this is an odd function, so it's going to give you negative 1 over tan theta. And since we know tan, that's going to be easy for us than using cos and sine. And negative 5 over 3. So our final answer is going to be 3 over 5. So for cos negative theta, we are going to get 3 over 5. So that is all for the first question. I'll be back for us to solve the second one. So we have the second question on the board. Given that sec x is equal to negative 3 over 2 and tan x is greater than 0. Find the value of the said trigonometric functions. Now wait. Before you quickly move on to find the value of all the said trigonometric functions, first identify the quadrant you are working with. Now, what is the quadrant? Here we know that sec the quadrant, the question is silent for that, but we can still get it. Let's move on. Let's see how we check for the quadrant. We know that sec x is negative here. I'm not considering the value itself, but the sign. The sign is negative in the question. And the reciprocal for cos is sine. Sorry, the reciprocal for sec is cos. Okay. So that is negative. So that means that cos is negative. So it can be in quadrant 4. Oh, I have put that part. It can be in quadrant 4. It failed to be in quadrant 4. Now, and don't forget, cos is just positive here. And cos is negative here. Cos and its reciprocal. They're going to be negative here and here. But here all the signs are positive. But from the question, it's negative. Okay? It's negative. So that means that it failed to be here. So it's whether on quadrant 2 or quadrant 3. Oh, tan x is greater than 0. That means that tan can't be negative. Tan can't be negative. And for tan cannot be negative, that means that it will fail to be in quadrant 4. And it will fail to be in quadrant 2. But it will not fail to be in the first quadrant. In the first quadrant, because for that, all the trigonometric functions are going to be positive. And it also satisfies the third quadrant because the tan is positive on the third quadrant. So what is the quadrant here? What is the quadrant here? Is it the first quadrant or the third quadrant? Now bear in mind, you cannot use tan x is greater than 0 only. Tan x is greater than 0 only to justify that it will be in the first quadrant, not even the third quadrant. But also consider the case that sec or its reciprocal cos is negative, and cos can be negative in the first quadrant. It can only be negative in the third quadrant. That is telling you, oh, I love this. That is telling you that the quadrant you are working with here is the third quadrant. So the reference quadrant is the third one. The reference quadrant is the third one. I hope it's clear. Very good. So let's move on. In case it's not clear, you can play back the explanation again for you to really know how to identify the quadrant. Now we move on to find the value of the said trigonometric function. So let's first go for. I will to first go for sine or cos, but let's see. From the question, we know that of sec x, which is negative 3 over 2. Oh, then once we know sec, going for cos will be easy for us. So let's go for cos. So sec x is 1 over cos x. I hope you can see that. Sec x is equal to 1 over cos x. That means that cos x is equal to 1 over sec x. So sec x from the question is negative 3 over Negative 3 over 2. Therefore, cos s is negative 2 over 3. Negative 2 over 3. Beautiful. 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 So that is that. Now watch. We are working in the third quadrant. And in the third quadrant, a sign is called positive or negative. That is negative. So no problem there. The cos is negative. Let's move on to sign. Let's move on to sign. So for sign, from what you know, which fundamental identity, when you link up, is going to help you to get sign? And that is going to be the first fundamental identity. Oh, sorry. And that's going to be from the Pythagorean identity, the first one. That is sin squared theta. Here we are using x for the angle. Sin squared x plus cos squared x, which is equal to 1. So sin squared x is equal to 1 minus cos squared x. Sin squared x is equal to 1 minus. What is cos? That is negative 2 over 3 all squared. So sin squared x is equal to 1 minus. Here we are going to get 4 over 9. And that is going to give you alright. So that is going to give you 5 over 9. 5 over 9. Therefore, sin x is going to be the square root. And whenever you take a square root, don't forget plus or minus square root of 5 over 9. Alright. So sin x is going to be plus or minus square root of 5 over 3. Then the question pops up. Is it going to be plus or minus? But don't forget, what is our reference quadrant here? The third quadrant. And in the third quadrant, only tan and its reciprocal cos is going to be positive. Therefore, sign is negative. Therefore, sin x is going to be negative square root of 5 over 3. Very good. I love this stuff. Let's move on to now cos is known and sin is known. So let's move on to, let me make here C. So A, then I will make here B, then next will be C. So which one? Okay, let's go for, since we know sin and cos, let's go for, let me check. All right. Okay, sec is also known from the question. Sec is known from the question. Okay. Let's go for cosec because we know sin. So let's go for cosec. So for cosec, very good. Cosec x. That is the reciprocal of sin. So that is 1 over sin x. So cosec x is going to be 1 over sin. And sin is negative square root of 5. How we can see that? It's negative square root of 5 over 3. And that is going to give you negative 3 over square root of 5. But we need to rationalize it. So multiply here by square root of 5, here by square root of 5. Therefore, cosec s is negative 3 square root of 5 over 5. And that is for cosec. But still, we are working in the third quadrant, and cosec is going to be negative since it's a reciprocal of sine. So no problem there. Okay, let's go for, since we know sine, we know cos, let's go for tan. Okay, so for tan, let me start from here. Or you can pause the video and continue to get the rest. D. We know that tan s is sin s over cos x. So what is sine? We know that of sine to be negative square root of 5 over 3. Negative square root of 5 over 3. And cos is 2 over 3. 2 over 3. Cos is negative 2 over 3 rather. Negative 2 over 3. Alright. So therefore, for us to get tan, therefore tan s is going to be equal to negative square root of 5 over 3 times negative 3 over 2. This cancel this, and again I get 4. So you're going to get square root of 5 over 2. Alright. So that is going to be that for tan s. And we are working in the third quadrant. So tan is positive. Very good. So leave it as positive. What the next thing? A, B, C, D, E. Let's go for E. Let's go for cos. Since we know tan quickly, let's go for cos. Cos s is 1 over tan s. Therefore, cos will be 2 over square root of 5. Quickly, that should be for cos s. And to find the reciprocal, you're going to get 2 square root of 5 over 5. So cos is going to be 2 square root of 5 over 5. And on the third quadrant, tan and its reciprocal is going to give you positive. That is why cos, the output is positive. Very good. I think we are done with all the 6 trigonometric identities. Therefore, set cos, sine, tan, cos, cosec. Oh, alright, then that's all. Let's move on to our third question. Okay, so we look at the third question. Express cos s in terms of tan s. Wow. We are going to express cos s in terms of tan s. What this means is that, for instance, y is equal to s squared plus 1 or plus s. This is y in terms of s. So for you to express cos in terms of tan, we want to get expression like cos s is equal to something. And that thing should be in terms of only tan. Now, which of the fundamental identities is going to help us here? Okay. We know that sec is related to cos x because it's a reciprocal identity. And also, sec is also related to tan. So we can say that 1 plus tan square x is equal to sec square x. Oh, okay. But we know that sec x is 1 over cos x. Hope not. Okay, keep following. So for you to get sec square is the same as 1 over cos square x. So instead of writing that, we write 1 over cos square x. And that is correct. So we now go on to make cos the subject. Wow, wow, very good. And for you to make cos the subject, this is going to be the same as cos square x is going to be equal to 1 over alright. That's going to be equal to 1 over 1 plus tan square x. Very good. Or you can write tan square x plus 1. It's also correct. So for us to get only cos to stand alone, we take the square root of both sides. And as a mathematician, anytime you take a square root, don't forget to bring plus or minus. So this one will cancel this, so this no problem. So cos x will be equal to plus or minus the square root of 1 over 1 plus tan square x. What do we have to do again? Now we know that we can still continue to simplify it. You can also choose to leave it like this because it's in terms of tan. You have to express cos in terms of tan x. So you can, but let's do something small. Let's apply our algebra small. Now, we know that the square root of 1 is 1. So 1 over the square root of 1 plus tan square x. How we can see that? Very good. And with this, we can even rationalize it. Cos x is going to be, yeah, let's choose it to be positive. Or let's repeat it. When you rationalize it, you get 1 plus make it a rationalization. You know this cancel this, so multiply 1 by the whole of this is the same thing, so this don't change anything. We are going to get square root of 1 plus tan x over, when this multiply this, bear in mind that the inside are the same, so you are going to get 1 plus. So it's like square root of a times square root of a. You get only the inside. Very good. So this is going to be the final result for that. And you can see that this is an expression of cos in terms of tan x. Very good. In terms of tan x. Now, We are leaving it in terms of plus or minus because from the question is silent on the quadrant we are working with. And you cannot say that, oh, it's the first quadrant. No, you can't guess for mathematics like that. So let's leave it in plus or minus. Alright. We were looking at the fourth question. Alright, so we look at our fourth example. Right tan theta plus cos theta in terms of sin theta and cos theta, and then simplify the expression. You can add your own completely. Expression completely. Alright, so we have this is the expression tan theta plus cos theta. But we know that tan theta is equal to tell me sin theta over cos theta plus, and we know cos is the reciprocal of tan. Therefore, if tan is sine over cos, cos will be cos theta over sine theta. Very good. Now, you see, if you have this, it's the same as having a fraction like half plus 3 over 4. The only thing you can do to simplify this is to ask yourself of the LCM. So in the same way, here is sin theta over cos theta plus cos theta over sin theta. So the LCM will be sin theta cos theta. And this cancels this multiply this. So you get sin square theta plus this cancels this multiply this. That is cos square. Oh, beautiful. In fact, in case you have forgotten all the fundamental identities, please go back and revise. As I said, you have to know all of them offhand. Because the moment you see the left-hand side of it, you have to recognize the right-hand side of it. Because from the particular identity, we know that sin square theta plus cos square theta is equal to 1. So the moment you see the left-hand side of it, which is sin square plus cos square, you have to recognize the right-hand side, and that will be 1. So let me close. But from Pythagorean identity, sin square theta plus cos square theta is equal to 1. So we get 1 over sin theta cos theta. Very good. You're not yet done. You can still continue with it. But let's be with it. Somebody can choose to write 8. Do you know that this is the same as 1 over sin theta times 1 over cos theta? This gives cosec. This gives sec. So this is cosec theta sec theta. It's the same thing. But let's leave it this way and go our way. Very good. Let's look at the 5th question. And that is simplify sin x. I'm lost. Okay. Cos square s minus sin x. Very good. So the fifth question is on the board and we have to simplify this. Let me repeat. Sin s cos square s minus sin x. Now watch. Sin is here, sin is here, so you can factor that out. So we are going to be left with cos square s minus 1. I'm going to be left with that inside. Then what's the next thing? Can we multiply through by negative 1? I'll tell you the reason why I would like to do that. The reason is that, watch, if sin theta plus cos square theta is equal to 1, therefore 1 minus cos square theta will be equal to sin square theta. I hope you can see that. Can you see that? Because when you set this to this side, this will be 1 minus cos square theta. That will be like a sin square theta. But looking at the inside here, cos square minus 1. This is not going to help us. Because from what we know, we have to get the cos square theta should be negated. But not the 1. Here 1 is negated, but not the cos. So let's multiply through by negative 1. So by multiply through by negative 1. And that will give you negative sin s. And the negative is going to affect the inside. So we get negative cos square s plus 1. Beautiful. So now you can see the inside. We can now rewrite it as sin s minus 2 plus 1 is the same as 1 minus 2. So this is the same as 1 minus cos square s. Beautiful. So but sin square s. So our sin square theta, I'm relating it to what I have here. So the argument will change. Here is x, here is cos. Here is theta, it doesn't change anything. So now, sin square theta is equal to 1 minus cos square. So here we have 1 minus sin square x. Therefore, the inside is the same as sin square x. Because we are simplifying it. So therefore, but 1 minus cos square x is equal to sin square x. Therefore, negative sin s and the whole of the inside is sin square s. So we get negative sin raised to power s. Sorry, yeah, sin raised to power 3x. And that is that for that question. Alright, we are at question 8.5. Okay, so we move to question 6. It's good to solve more questions. Okay, so let's move to question 6. And that is simplify cosec square s 1 plus cot s minus 3. Very good. We have to simplify this. Don't forget we are not to solve it, but we have to simplify it. Solving it is a different form. simplifying it. So please, I think there is a mistake here. I'm coming. The place supposed to be plus or minus. All right. Let's move on. Let's move on. So that's what we have on the board, and here we can simplify this. Here is cosine square s. To be, oh, let me check this. All right, please change the question. I think there was a typing mistake in what I have here. So this is the correct one. We have to simplify this. Okay, very good. Now, to simplify this, note that here the trigonometric functions, they are not the same. One is cosec, one is cos. So we have to change it. We have to change it so that we will get it in the same function. And what can we do that? Okay. We know that from the Pythagorean identity, cosec square x is equal to 1 plus cos x. Oh, cos square x. Very good. So instead of writing this, we can write 1 plus cos square x minus, don't forget we are doing substitution, so this is this, minus cos x minus 3. Now this is going to give you cos square x minus cos x plus minus 1 minus 3, not plus. No, you. 1 minus 3, you get minus 2. So you can see that this is in the same function because it's called cos. Just that one is squared and the other is not. But it's still the same function. We can do something to it. Alright. So what we can do to it is just simple. You can do it in two ways. You can put cos to be equal to y, or put cos to be equal to m. And you get m squared minus m minus 2. And this is a quadratic equation. Beautiful. How we going to do that? Very good. And with this quadratic equation, when you solve, you are going to get m to be 2 or negative 1. Alright? So when you bring it back, you get m minus 2, m plus 1. But you know that m is what? Cos. Don't write, stay with that, remember. And you know that m is cos. So it is going to give cos minus cos. It's going to give cos s minus 2 cos s plus 1. And that is all. You have simplified it, correct? Very good. But here, that one you can choose to know. I don't want to replace it by any variable. I'll go for it by using the cos. No problem. But know that with this, that is going to give you the same thing. That is cos minus 2, and that is cos s plus 1. The same thing that you're going to get. But the result you are going to get is cos s is equal to 2 or cos s is equal to negative 1. And when you do that, you're going to get the same thing. Very good. Very good. Is there any other? All right. Let's look at this question. All right. I think with this, we have solved similar with question 7. There are some similar ways. So please pause the video and try it on your own. But don't forget, we have to use the trigonometric identities. Okay, I know that with this you can use this to do it. Okay, because you know that sin theta is y over r. Okay, so to be given 1/3, and for the question it says we have to work it in the. I want to show something to you. You can use that method, but that is not what we are in need of here. We are to work in the second quadrant, so that means that the formula will form here. Okay, that means theta is forming here. So this means that y here is r, and that is 3. Y is 1, and s is what you don't know. So we can use Pythagorean identity, and we are going to get the same answer. S squared plus y squared is equal to r squared. And here s squared plus y is 1 squared is equal to r. R is 3 squared. And s squared is going to be equal to 9 minus 1. And we are going to get the s here to be the square root. That's going to be the square root of 8. The square root of 8. So this is square root of 8. So since we know sin is already 1/3, we can now get cos theta. That is s over r. Now the s is square root, so square root of 8 over r. R is 3. So cos theta will be square root of 8 over r. Then we go for tan. In case that will be needed. And theta is y over s. I just want to prove something to you. And that is going to be 1 over square root of 8. Alright. So you see we can use that one together. Cos theta is going to be square root of 8 over 3, and tan is going to be 1 over square root of 8. But that is not what we want you to use here. From the question, he says using the trigonometric identities, but not this. When you do this, well, it depends on the examiner, alright? But for me, I'll mark you wrong because I have to mark you down because that's not the method we are looking for. So you have to use the trigonometric identity. So from Pythagorean identity, we know that sin squared theta is equal to plus cos squared theta is equal to 1. Okay. So that one will be easy for me to get. Okay, and that is 1 minus 1 over 9. And with this, you can get cos theta. Go for it. Go for it with this, you get cos theta. Alright. And with this, that is, this is 9 over 9 is 1. So you get 8 over 9. Okay, so this is 8 over 9. Alright. So that will be for cos theta. So that is square root. So for you to get cos, then you take the square root of both sides. So cos theta will be equal to square root of 8 over 9. And that is square root of 8 over 3. Hope you can see that. Very good. But don't forget that here we are working in the second quadrant. Therefore, cos is negative. Don't forget that. And if you are using this idea, you can also use the idea that when you are working in the second quadrant, cos is negative. Or you know that on your OS and OY plane, the values for S here is negative. So this is negative square root of 8. So when you negate that here, you are going to get that. And even with this, it will be negative. So please, solve for time. You are going to get this result. But don't use this method. This method is correct. I hope you can see that it's correct. But I want you to use the Pythagorean identity. So with the time, you can use sine over cos and go your way. Alright. One more. Last one. Given that, question 8, given that tan theta negative 5/4 and cos theta is greater than 0. Next question. Find sin theta and sec theta. Find sin theta and sec theta. Here, the question is open. The question is open. It's open because it's not restricting you on a particular method to use. Whether you are to go for Pythagorean and the fundamental identities or not. So yeah, you can choose to use the first method, the one that I showed you. You can choose to use that. Okay. So let's go for that. Let's use that method. That one is very short. But the rectangle triangle that we are going to draw, is it going to be in the first quadrant, the second quadrant, the third quadrant, or the fourth quadrant? Knowing that is very, very, very necessary as far as this course is concerned. Because if you don't know that, how are you going to do it? In fact, with the two methods, you have to identify the quadrant first. Now watch. Tan given in the question is negative. Very good. All students take calculus. So tan is positive here and positive here, but negative here and negative here. So for tan to be negative here means that it can be whether the second quadrant or the fourth quadrant. But that only don't justify the case. Let's continue. And cos theta is greater than 0. Oh, so that means that for the result of a cos theta to be greater than 0, that is telling you that cos can be negative. And for cos can be negative, that means that it will be positive. So let's check. We are saying that for tan to be negative, then it can be in the second quadrant or the fourth quadrant. But we are saying that cos is positive because it should be greater than 0. And cos here is negative, so it fails to be in the second quadrant. So the quadrant where tan, which is negative, and cos, which is positive, is going to satisfy perfectly, completely, is quadrant 4. Is quadrant 4. So here we are using P4, quadrant 4. Very good. So you go and sketch it. So it's going to be in quadrant 4 and going to mix with the SR. Hope you can see that. Very good. So theta will be here. Y is equal to what? S is equal to what? R is equal to what? Now, we move from node to unknown. We know that tan theta is y over x. So 5/4, negative 5/4 is going to be here. Now, which one is going to be negative? Note that with the values here, y is negative, so the negative 5 will be here. Then s here is positive, so here will be positive 4. For r, no, We can get the R by using the particular identity that x squared plus y squared is equal to r squared. So there is no problem for it. The x is negative 5 squared plus, s is 4. Negative 5 whole squared is equal to r squared. So when you solve, you get r to be equal to, square root of 41. But don't forget, it's whether it will be plus or minus. Then you go and check. You know that the r is radius and distance can be negative, so it's rather positive. So r is equal to square root of 41. So now that we know that, then we can conclude with the question. We have to find sine theta. Quickly, sine theta is y over r. So what is y? Negative 5 over r. And that is square root of 41. You can rationalize it, and you are going to get negative 5 square root of 41 over 41 when you rationalize. Secondly, you can go for sec theta. Simple. That is 1 over cos theta. And what is cos theta here? Cos theta is s over r. You see, all these things, you have to get it here, okay? Because that's coming from the idea of so after 8, you don't normally use the SOCA. That is SOCA tua. Okay? SOCA tua. SOCA tua. Very good. So for SOCA tua, you see cos is adjacent over hypotenuse. So the adjacent is the S and the hypotenuse is the R. So just quickly S over R. Go with it. And that is going to give you 4 over square root of 41. And when you rationalize, don't even rationalize, you're going to do the substitution here. And that is, so to look for sec, 1 over 4, and that is 4 over square root of 41. Therefore, we end up by getting sec to be square root of 41 over 4. That's all. And we know that for sec, for the fourth quadrant, cos and its reciprocal is positive, so sec is positive result. Okay. And what again? Sine. For the fourth quadrant, because we are working the fourth quadrant, so you have to always reference to that. For the fourth quadrant, sine is negative. And what the result for sine? Alright, that is all. I'll project some questions for you to try it on your own. Alright. Now, in our next video, we are going to look at verifying identities. Verifying identities. That is, you'll be given a function to verify whether it is the same as the one on the right hand side. Okay. And that one will see you in that video. I don't want to talk much here. Alright.